This is video number 1 for sections 7.6 and 7.7, solving systems of equations with 3 variables. This lesson is about how to find the equation of a parabola, of a quadratic function, when you don't know the vertex. If you know the vertex, you just use vertex form, and we covered that earlier in the chapter. But what if you don't know the vertex? How do you find the equation? In order for me to teach you that, I first need to show you some background algebra, and that algebra is how to solve what is called a 3 by 3 system of equations. In other words, a system that has 3 equations and 3 variables. And that's what we'll talk about in this video. You can see down here an example of such a system. We did systems a long time ago, back in chapter 3. We did 2 by 2 systems, meaning 2 equations with 2 variables. And now we've got x, y, z, 3 letters and 3 equations. The goal of solving such a system is similar to what we had back in chapter 3. We just want to find values of those 3 variables. So when I'm done, I'll have an x, a y, and a z, and what will be special about those 3 numbers is they will make all 3 equations true. Well, there is a series of steps that you need to go through in order to solve such a system, and so let me demonstrate that for you in this example problem. The primary new step is this. When you start out here, you have way too many letters, and you need to choose one of those letters and get rid of it twice. Let me say that again. You need to pick a letter and get rid of it twice. It could be the x's, it could be the y's, it could be the z's, whichever you think is easiest. And you will get rid of that letter twice using the method of elimination. What some people find helpful in these problems is to number the equations. There are so many equations that we're going to deal with, and so just numbering these, maybe equation 1, equation 2, and equation 3, we may find that helpful. Well, when I was looking at this, what caught my eye is that if I were to add equation 1 and equation 2 together, that's the method of elimination, right, where you add the equations together so that one variable drops out. I noticed that the y's would drop out. So I decided in this problem that I would get rid of the y twice. Step A says let's use elimination on those first 2 equations to get rid of the y. So let's write those 2 equations down, and then all I need to do to get rid of the y is to add these equations together. I have 2x plus 3x, 5x, the y's disappear, 2z and negative 1z makes positive 1z, so plus z, and 6 and 5 makes 11. I'm going to call this equation now equation 4, because I'm not done with this. I'm temporarily going to step away from it, but I'm going to use this in just a moment. Before I do, however, I need to get rid of y again using a different pair of equations. Essentially, every time you work one of these problems, you have 3 different pairings you can use. You can use equations 1 and 2, you can use equations 2 and 3, or you can use equations 1 and 3. You're going to pick 2 of those options. We did 1 and 2 already. Now we're going to do 1 and 3, the first and third. Why did I pick those? Only because I noticed that in the first equation I already have a minus. In the second, or rather in the third equation, I already have a plus. I'm figuring that'll make my life easier. Let me jot down those 2 equations. Now this time I am not ready to just add these equations together. Remember, that only helps me if one of the letters drops out, and actually specifically it's only going to help me if the y drops out. I have to get rid of that same letter twice. Right now that wouldn't happen. Well, remember back to chapter 3, we would use a multiplication trick, and it looks to me in this problem what I need to do is I need to take this top equation and multiply it through by 2. That will change this to a minus 2y, which is what I need to have there so that when I add to the other equation, I'm all set. Let's go ahead and carry out that multiplication, quickly multiplying everything by 2. I get 4x minus 2y plus 4z equals 12. It's all or nothing, so make sure you multiply everybody by that 2. Now I can take these two equations and I can add them together, and the y's will disappear. That's going to give me 5x, the y's are gone, plus 5z equals 15. I have just gotten rid of the letter y twice. Let me call this new equation now equation 5. Well, continue on. Once you've gotten rid of one of the letters twice, look at part C. Now what you have in those two answers we got in parts A and B, equations 4 and 5, those two equations together form a system of two equations in two variables. In other words, a 2 by 2 system. They make up the kind of system that we solved back in chapter 3. Let's copy those equations down now. Now we're just doing what we've done before. This is just a system like we had back in chapter 3. Two equations, two variables. Once again, my next step is to rid myself now of one of these two letters using the method of elimination. I'm clearly not ready yet to add the equations together because neither variable would drop out. I can get rid of whoever I want. I guess the one that looks easier to me is the x's, because all I would have to do is take one of these equations and multiply through by -1. That would make this a negative 5x, and so then I can see it'll cancel out with the other positive 5x that's already there. So we'll do that quickly. Change all the signs in the top equation. And then I'm ready to add together these two equations. 5x minus 5x, gone. 5z minus z, 4z, and 15 minus 11 is 4. That essentially then makes the sixth and final equation. And this finally is the best one because there's only one letter in it, which means I can solve now for z. Simple algebra, and in one last step there, I get z equals 1. What did we do next in chapter 3? Well, remember I had x's and z's here. So once we found one of the letters, we would just plug it back in somewhere, right? Somewhere in one of the earlier equations, so that we could get the other letter. Let's go ahead and do that. You can pick either of these equations, equations 4 or 5. Equation 4 looks pretty nice to me because it just has the single z there. So if I plug that in, that gives me 5x plus 1 is my z value, equals 11. And just a couple of simple algebra maneuvers here, and I will end up with x equals 2 as my final value of x. Okay, am I finished with this problem now? Well, I'm getting there. And maybe just so I don't lose anything, I think I'm going to circle these sort of pieces that are part of my final answer. The one thing that's missing still is the y. How are we going to get that? Well, letter D says, now we have to go back to one of those original equations, equations 1, 2, or 3, and once again fill in the letters that we've already found so that we can figure out the y. So we'll have to go back up, take a look at equations 1, 2, and 3, and whichever one looks to be the easiest place to plug into, I think that's the one I would choose. I guess the one that catches my eye is the second one, because the letter y is already, kind of sitting there without a coefficient or anything. I'm going to take this equation, I'm going to copy it down below, and then I'm going to fill in the pieces that we found already. So I know that the x is 2. I don't know the y. I know that the z is 1. All I got to do here is solve for y. Looks like I've got 6, take away 1 would be 5 plus y equals 5. And when I do my algebra, I'm going to end up here with y equals 0. Once you have your three values, your x, your y, and your z, you're finished with this problem. And the way we generally state our answers is as an ordered triple. So we've been using ordered pairs. This would be an ordered triple. The order matters. It has to be alphabetical x, comma, y, comma, z. And so for us, that would mean the final answer is 2, comma, 0, comma, 1. In this box here at the bottom, I've summarized for you the list of steps that we went through. Keep in mind that just like the problems in Chapter 3, these problems are very, very easy to check. All you have to do is go back to the 3 equations and one at a time plug in this x, this y, and this z and make sure that all 3 equations really do come out to be true. We'll continue to practice this skill in the next video, and then later in the lesson we're going to use this skill to help us to find the equation of a parabola.